Hello everyone, I'm Dr. Godan Raman. In this section we are going to discuss with eigenvalue, eigenvector, the third type of the problem, symmetric matrix with repeated eigenvalues. Look at the problem. Find the eigenvalue, eigenvector of the matrix A given 3 row 3 column. So matrix of order 3. First you write the characteristic equation A minus lambda I determines 0. For this 0 minus lambda the form 1 1 and 1 0 minus lambda 1 1 1 0 minus lambda. So this is a characteristic equation form. A is the square matrix, I is a unity matrix, then lambda is a eigenvalue. So now to expand this as usual the normal form or using this cubic polynomial. Once this characteristic when we have to expand, it will coming with the cubic polynomial lambda cube s1 lambda square s2 lambda minus s3 equal to 0. So this is our cubic polynomial for this given matrix. Now to calculate s1. So what is the s1? S1 is nothing but sum of the main diagonal element. So this is a given matrix. Now what is the diagonal? Main diagonal. This is the only I am taking. Therefore sum of the main diagonal 0 0 0 s1 0. Then s2 sum of the minors of main diagonal elements. Therefore now I am taking this first one, I am taking this matrix. So the first diagonal, this 0 is the first diagonal. I am selected this 0. Now when I selected to find the minor matrix, to leave this row and this column. Okay. Now other, this is our minor matrix 0 1 1 0 plus. So another minor matrix to calculate second another diagonal. This is another, I'll take it. When I'm taking this another diagonal, now again you just leave this row and column. We have the value minor matrix 0 1 1 0 plus. Then the third diagonal, now I'll take this third one. This is our third diagonal I am taking. This third diagonal again to leave ignore this row and column. Therefore we have 0 1 1 0. Now to calculate 0 minus 1 plus 0 minus 1 plus 0 minus 1 s2 minus 3. Then s3 is determinant of A. S3 is determinant of A. Therefore now this determine 0 1 1 1 0 1 1 1 0. Now to calculate this normal manual expanded method or using calculator, both the previous video I have updated. Please refer the previous video link I will be provided here in this description. So now this formation I'll consider when I'm choosing this first one. Okay, when I'm choosing the first one, therefore this actually plus minus plus minus plus minus plus minus, this is a form when plus minus plus, when I am selected here So to calculate this, determine when I selected 0, 0 into any minor matrix 0, then next to minus 1. When I'm taking this minus 1, so 0, 1, 1, 1, 0, 1, 1, 1, 0, this determine. So when I selected this 1, now you just leave this row and column. Which row? The first row and the second column. Then this is our minor matrix 1, 1, 1, 0. Then plus 1. The plus 1 again 0, 1, 1, 1, 0, 1, 1, 1, 0. When I'm taking this, when you selected this third element, now this row and the third column, when you ignore this, we have the value 1, 0, 1, 1. So therefore this minus 1, 0, multiplication 0 into 1, 0, and then minus 1 plus 1 into 1 minus 0, therefore 1 plus 1, S3, 2. Now what is the S1, S2, S3 value? S1, 0, S2, minus 3, S3, 2. Now you substitute this value to the cubic polynomial, lambda cube, S1 lambda square, S2 lambda, S3 equal to 0. Now the lambda cube minus 0, then minus 3 lambda, then minus 2 equal to 0. Now the form lambda cube 3 lambda minus 2 equal to 0. To solve this equation using calculator method or long division method. So which is you have convenient, then try. Now this problem I'm using long division to take the coefficient of the value 1, 0, minus 3, minus 2. When I'm taking 1, this 2 write directly here 1. 1 into 1, 1. Now you add this to 1. 1 into 1, 1, minus 2. 1 into 1, minus 2, then minus 4. When it's equal to 0, then it's one of the root or one of the eigenvalue. When it is not 0, this is not your eigenvalue. So now you try next 1, 0, minus 3, minus 2 to take minus 1, any number. Now this one I'm writing here, minus 1 into 1, minus 1. When I'm adding this 2, minus 1, minus 1 into minus 1 plus 1, minus 2, minus 1 into minus 2 plus 2, then 0. When equal to 0, then this is a root. Lambda equal to minus 1 is one of the root. Then next you continue this or write this equation into the quadratic form. I'll take again minus 1 or 1, whatever. First I will take 1. When I'm taking 1, 1 into 1, 1, 0. 1 into 0, 0. So now minus 2 is not equal to 0. So this is not possible. Therefore next I'm going to try with minus 1. Next I'm going to try with minus 1. So this one when I'm writing here, minus 1 into 1, minus 1. Adding this minus 2, minus 1 into minus 2, 2, 0. So this is another eigenvalue. Then minus 2 when I'm looking here, so take 2, 1 into 2, 2, 0. So this is a third eigenvalue. Therefore the eigenvalue is nothing but 2 minus 1 minus 1. So this is our eigenvalues. So what is the type of this problem? Symmetric matrix and repeated eigenvalue. So lambda is minus 1 is a repeated eigenvalues. So repeated eigenvalue. Therefore to check the given matrix A is symmetric or not. Therefore A matrix is nothing but This is our A matrix. Now this A matrix to write A transpose. Now row to write in the column 0 1 1. Second row into the column 1 0 1. Third row into the column 1 1 0. Therefore look at this, A equal to A transpose. The both matrix are equal. Therefore A is symmetric matrix. Now to find the eigenvector. So now I checked here, the given matrix is symmetric matrix, repeated eigenvalues. Now you write the eigenvector form. So eigenvector form. So eigenvector is nothing but A minus lambda I. To find eigenvector, A minus lambda I, the matrix capital X is 0. Now what is the form of this? A minus lambda I. So this is our matrix, same form, A minus lambda I determined. So I am just copying this, A minus lambda I. Now capital X. So capital X is nothing but the variable of x1, x2, x3. If you want to take x, y, z, you will take it not wrong. So 0, 0, 0 for right hand side value. Now I consider this is the equation number 1. So therefore, now first eigen value, you just any eigen value to take it. So no issue. Now I am going to first to find the eigen value, eigenvector. So the eigen value is lambda. So what is the lambda value? Lambda 2 minus 1 minus 1. So first I am going to take 2 in substitute equation 1. When I substituted here, this is a minus 2, 1, 1, 1 minus 2, 1, 1, 1 minus 2. This is the one of the matrix. Now x1, x2, x3. 0, 0, 0. Now when I multiply row into column, we have all the three equations. When I multiply, we have three linear equation, 2x1, x2, x3, 0. Then x1 minus 2x2, x3, 0. Then x1, x2 minus 2x3, 0. Now you choose any two. Please don't take it similar equation. If you are similar equation, if you are taking, the answer should be 0, 0, 0. So therefore x1 by minus x2 by x3. So this is the form of writing plus minus plus. Don't get confused here. x1 plus x2 minus x3 plus. Now x1 when I'm choosing here, when this part, this is our minor matrix. Therefore 1, 1 minus 2, 1. Then the second when I'm choosing x2, minus 2, 1, 1, 1. Minus 2, 1, 1, 1. Then the third one, when I'm taking this third one, minus 2, 1, 1, minus 2. Therefore, x1 divided by 1 minus of minus plus. So 1 plus 2. Then minus 2 minus 1. Then 4 minus 1. Therefore, 3 minus 3 plus 3. When minus will be cancelled. Now to remove this 3, it's a factor. The common divisor 3. To remove this 1, 1. If you are not removed to continue with 3, not wrong. So this is the x1 first eigenvector 1, 1, 1. When lambda 2, the eigenvector 1 is 1, 1, 1. And then lambda is minus 1 in equation number 1. So therefore I'll take it this equation. This is our equation number 1. In this equation, to substitute lambda minus 1. To substitute lambda minus 1. So when I substituted minus 1, 1, 1, 1, 1, 1, 1, then 1, 1, 1. So this is a 3 cross 3. So when I multiply row into column, so we have the equation x1, x2, x3, 0. Then second equation also same equation. So all the 3 equations are same equation. Look at this, all the 3 equations are same. So you have only to consider one equation. This is the only we consider only one equation. So for this equation, you just take it, anyone to take 0. We already mentioned that anyone to take 0. Now the equation x1, x2, x3, 0. So this is the equation. Now to take x1 0 or x2 0 or x3 0, anyone to take, it's your point. Therefore now I'm taking x1 0. When I'm substituting 0 plus x2 plus x3, 0. x2 equal to minus x3. x2 equal to minus. What is the meaning this? x2 denominator, it's meaning 1. Then x3 I consider minus 1. Therefore when lambda minus 1, then the second eigenvector 0, 1, minus 1. So this is a second eigenvector. Now the problem is symmetric. So normally non-symmetric, now you same equation to put the value any other x2 0 or x3 0. But in symmetric don't do that. Now lambda minus 1 when I'm taking, now the third eigenvector to consider for orthogonal. So x3 is equal to consider a, b, c. A, x3 is nothing but a, b, c. Here x3 is orthogonal to x1, x2. x1 and x2, 2 eigenvector. Therefore what is the orthogonal transformation? X transpose, suppose I will consider x3 here, x1 transpose into x3, then 0, and x2 transpose x3, 0. So these are the orthogonal. The x3 is orthogonal to x1, x2. Therefore the given matrix is symmetric. So now should write this x1. So x1 matrix is nothing but 1, 1, 1. This is the x1. When I'm taking this transform, x1 transform, column to write in the row 1, 1, 1. So what is the x3? I'm just taking a, b, c. Therefore x1 transform x3 0 is nothing but 1, 1, 1 is the x1 transform. x3 a, b, c. Then the right hand side value 0, 0, 0. Or you write 0, because I'm going to write linear equation, not a matrix, so better I'll take 0. Now row into column. What is a row into column? A plus b plus c equal to 0. And then next x2 transform x3 is orthogonal, then x2 transform is nothing but what is x2? Second eigenvector. Second eigenvector. So what is the second eigenvector value? The second eigenvector value 0, 1, minus 1. Therefore x2 0, 1, minus 1. Then x2 transpose, change column to row, 0, 1, minus 1. Then x3 A, B, C. Therefore x2 transform x3 0 is nothing but 0, 1, minus 1. Then A, B, C is equal to 0. Row into column, so 0 A, B, C equal to 0. Now to take this two equation, what is the equation? Now you just take it. This two equation is our two linear equation. So very simple. First eigenvector based on one linear equation. Second eigenvector based on the another linear equation. So A plus B plus C 0. 0 A, B minus C 0. When from this equation, if you have confusion for this, take it x1, x2, x3 also. So for here A by minus B by and C by. So when I'm taking A, the minor matrix is nothing but 1, 1, 1, minus 1. So 1, 1, 1, minus 1. Then when I'm selected B, 1, 1, 0, minus 1. 1, 1, 0, minus 1. Then the third when selected, this is our minor matrix 1, 1, 0, 1. 1, 1, 0, 1. Therefore A by minus 1, minus 1, minus B by minus 1, 0, and C by 1, minus 0. Therefore A by minus 2, B by minus 1, C by 1. When minus will cancel, so lambda minus 1, then the third eigenvector is minus 2, 1, 1. This is our third eigenvector. So thank you everyone.